Okay, so we're going to do something slightly different in this video here. I'm going to talk to you today about signals. So signals mean the clues that are presented in a question, whether it's keywords, the way that things appear as they're written on the page, all kinds of things. And when you master signals, it gives you a pretty good way of quickly getting into a question. Okay, so some of them might have references at the top in bold. I'm not going to read those. I leave them for you if you want to pause the video. And this is a shadow version that I've made with the website Dr. Frost. Okay, so I've taken the specimen paper and made a shadow question. So if any of the questions are from anywhere else, of course, that's all their questions. But I thought they'd be useful for us to kind of talk a little bit about this. And along the way, I'm going to talk about why signals are important as well. What I'm not going to be doing is answering full questions. So here we go. So the first question is about describing a transformation. So it says describe the transformation from here to here. Okay, so what this one's all about for us really is this is all about comparing. Okay, so comparing results is massive in A level to spot what the question's all about. So I noticed the limits are exactly the same. This looks very, very similar. The only thing that I can see that's different is in the power. I've got this one here and this one here. So, well, how do they compare with each other? Because, for example, I might know the answer for this and I might be asked about this one. So what we need to realize is that this is about powers, isn't it? So 2 to the 5 minus root x times 2 to the 1, for example, leads you to that result there. So these two things are related to each other. It's just that one of them is going to be twice what the other one is. Yeah, the one that is the bigger one, you'll be able to write it in this format, okay, because you can pull numbers out to the front of an integral. So this is all about noticing small differences and appreciating that when they seem really, really similar, you need to use a relevant rule, which is about power rules. So I would say this is all about comparing, and this is about indices, okay, indices or powers. It says describe the transformation, so it's something about stretch of 2, isn't it? Okay, that's what they want us to do. For our next question then, so let's have a look. I haven't seen these questions before as well, by the way, okay? So I'm going into this, fairly blind, okay? So I'm just using the signals that I've picked up from answering so many of these questions before. So when we're looking at this, first things I'm thinking here is this looks like some sort of e to the x graph, maybe e to the minus x, or something like that. Okay, and I've picked this here because this is always a really, really crucial point. So we expect this point to be 1, and I can already see over here some sort of stretch or something like that. So if it's not going to be 1, that means that this is going to be down to this part here. Okay, and in fact, as I scan, do you see here it's got a 0, 4, so straight away I know that A is 4. Okay, so what I'd be doing for the rest of the question is I write in information that I know, because when you're not sure what to do, just making small steps like writing something in there gives you some ideas, doesn't it? Okay, what else do we do if we've got something and we're not sure what to do? Well, subbing in those results is probably going to be quite a good idea. Now, it's actually about the trapezium rule, but I suppose the idea is you need to know what the equation is before you use the trapezium rule. Do not forget that the trapezium rule is in the formula booklet. Okay, it's in the formula booklet. The only thing you've got to be really a bit careful about is making sure that you set h as the correct value. H in the trapezium rule talks about this distance here. It needs to be the same for each of them. Okay, next, what have we got? Right, as soon as you see that, integration. It's integration because integration is going to give you the area between a curve and the x-axis. It also does it sort of in a tunnel, I always like to think of it, yeah? Between between vertical sort of parts there. So if we integrate whatever this thing is, that would take us straight to this value. Explain how the trapezium rule, so we're imagining, comparing integration to the trapezium rule on this one. So what's the idea? Well, the trapezium rule and integration are sort of the same thing. Okay. Integration is when you use the trapezium rule with very, 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 very tiny widths on your trapezia. So this is an easy to answer question. All you do is say, if you have more trapezia or they are narrower, you get a better answer and you will get closer to the integral, which is the real answer. Let's keep going. Find the first four terms in ascending powers. Right. Terms, yeah, some sort of sequence. Ascending powers, this is a big clue that you've got binomial. Okay, so this one here, we want to make sure that we've got the A level section, not the AS, the A level section of our formula booklet open, because that's got both binomial expansions, and we want to identify that we have a fractional or a negative power here. So this is going to be, the expansion of 1 plus nx plus n, and so on and so on and so on. Make sure when you're doing this, please, that the value that you are calling x is going in here and all being squared. I'll just get you started on that question. So when you look at the booklet closely, it will tell you that this needs to be a 1. So the idea should be here that you factorize an 8 out. 1 plus 3 over 8x, 8 to the third, so let's just write this one more step, 8 to the third, which is 2, sits out the front, sits right at the end of the question, and then the question that you're answering really is the expansion on this, okay? Careful with your signs, careful with your fractions. I would even suggest you write out n equals a third. The bit that is called x is not x, it is a positive 3/8 x. Okay, if you do all of this stuff, well done, you're going to get the marks. Easy. If you don't and you are careless, you will be throwing them away. Okay, so please make sure that you are methodical with that one there. Next, as part of our expression, so you'll notice in the Dr. Frost, the A and B are not necessarily connected in the real paper, so that's why I'm going so quickly. Validity. If you see this, the question 9 times out of 10, and it's in the formula booklet, is about this idea. Okay, so here, the x bit is 2x. So whatever this is, you just dump it in here. Don't worry about plus, don't worry about minus. Put that in there, okay? And then you go like that. It's like 1 mark. Easy if you know how to do it. Next. So what have we got here? We've got something about some sort of fraction or something like here. So what would I be doing in this question first? So what I'd be doing is I'd be scanning for the biggest powers. Squared x. Okay, so I'm looking to see if this is top heavy or not. Because if it's top heavy, I have to divide fractions or something. So this one I'm thinking in my head here is not top heavy. So again, I'm just telling you my thought process as I'm reading these. It's not top heavy. I've got some values I'm not allowed. So what's this question actually about? Write this in the form where you could use the binomial expansion. Okay, well, that sort of surprised me a little bit. So what they seem to have done here is they seem to have done the partial fractions for me, because that's what was going on in my head. Why was that going on in my head? Because I have a product, yeah? I have two things being multiplied in the denominator look like this. So they've done that, and then they've said, how would you use them? Well, the idea is this first one here, you would write this as 5x plus 2 to the minus 2. And then you'll remember that we have to do 5 to the minus 2. Don't forget to do that. 5 to the minus 2. X plus 2 over 5 to the minus 2. So you have to do your first expansion like that, and you have to work all of that out. Okay, and then the other one over here, there was a plus sign in the middle there. You would have to write this as 1 minus 2x to the minus 1. Notice it's got a 1 already, so that one is nice for us to expand. Okay, sequences. Not the worst idea when you're first confronted with a sequence. Not the worst idea to just work out a few and see what's going on. If you find out a few, it's going to be much easier. Make a list of them as well. You'll find that you get all kinds of weird patterns. So I've got 15 and then 20. Well, this is just saying 20 minus this is the next one. This is the one before. So this is 15, and then this is 20 minus 15. So it's going to be like 5, isn't it? And then the next one would be 20 minus 5. Okay. So you find out what's happening just by working these out. And then it's a common question to say, there's two sequences really. There's a sequence of 15s and there's a sequence of 5s. Okay. And maybe I add them together or something might be how that question would go. What have we got next? So we've got this symbol here. Right, 48. 48 is quite a lot of terms. So I'm probably going to have to do something nifty. And then this, I would imagine, would turn into arithmetic or geometric, where I'd be using n as 48. But obviously that's really not that obvious from the start. So this question looks like it's got a bit of an edge to it. In fact, I'm just quickly thinking about if the question is appropriate, because this is the only issue with question generators. What I would do to get an idea of what's going on, as I said before, is it's not a bad idea to sub a few of these results in. Just thinking what this question looks like from very briefly reading the mark scheme on this one. I'm not sure this is one that is going to be appropriate for us. Okay. Next. So position vectors. Position vector. A position vector, if somebody gives this to you, first thing you want to do normally is roughly sketch where it is. So 7, 2 means it's here. So thinking of position vectors as coordinates can be very, very helpful. Find the distance. Distance is a word that means you're doing Pythagoras, aren't you? You're finding the magnitude of something. OA. OA, two capital letters next to each other. That suggests, a length. O is the origin. You should know that already, really. Okay, so there we go. This is clearly a Pythagoras question. Okay, it's clearly a Pythagoras question. Relative to O, position A has this vector here. Now, something that lots of people don't think they can do is they think that, I can't sketch this. This is because it's 3D. Well, why not? Okay, give it a sketch and it will help you think. You don't have to have everything worked out. It's just a tool to help you think. So I'm going to put A there. I'm going to put B, say, over here. D has a position vector here, right? As soon as we start getting in the position where we have 3 coordinates, I'm thinking it's going to be something about a shape. And it's useful to think about shapes being labelled in a clockwise or anti-clockwise fashion. So D is minus, right, I'm just going to chuck D here because, in fact, I can already see ahead. A, B, D with C are some points. So maybe I might go like that just to make it clear. I don't know. So what's this question going to all be about? Well, they tend to give you shapes like parallelograms and trapeziums, things like this, because you know things about those shapes. So, for example, if it were a trapezium, saying that A to B and D to C or C to D, either work, are parallel is the way that this question would be cracked open, okay? Or if in this one, parallelogram, so what's special about a parallelogram is they're actually the same length, aren't they? So that quick sketch there, labelling clockwise or anti-clockwise, as I've done, will enable you to identify the right vectors to look at. And parallelogram and so on, these are really big signals that you need to use properties of shapes typically for this one. Okay, right, I can tell you without looking any longer, px, so this is a polynomial, you don't know something, so they're going to give you something to substitute in, and you're going to find p. Right. A factor. So factor theorem, minus a half. All right. So you want to use x equals minus a half, y equals 0. Sub them in, just write it without any simplification to score the first mark, and you will get p. We're going to do a couple more. So, right. Massive giveaway. Log 2, log 2. Same log means if they're the same base, you can use power rules. What do you do here? You do stuff like this. Chuck the squared up there. Okay, this one here, 3x plus 5. Oh, I'm glad that they asked the question like this. What do we not do next? We do not do this. Absolutely not. Okay, you're not allowed to do that. So if you want to apply 2 to the power of, this is the meaning. That's one way that you can answer the question. But I always find that students are slightly hesitant to do that. They don't seem to like doing that. So one way that you might want to do this question is you might want to subtract. So if you did this minus this equals 1, you'll probably then be fairly confident doing this. This is the log rule part. Then you could do your rules. Okay, so when you've got sort of one thing on both sides, not this. Okay, please don't go blindly doing 2 to the power of 2 to the power of and so on when you're doing that. That's not the way forward. Okay, this one here, I don't think we'll talk about this because it's so similar. Move the 2 up, get these 2 parts together. Don't forget to check your answers. Your answers must always be okay with the initial thing given in the question, please. Okay, quadratics. So modelled quadratics are really, really common. I've just spotted something in the question that they've been too nice to you, okay? So a quadratic, a linear, it's really important that, you know, that linear could be written like that, or mx plus c, or if it were, for example, exponential, that it might be something like this, or quadratic in this case should be written like this. It should be written like this, or perhaps this is an acceptable version of it as well, or even a completed square version. But you cannot just write, okay? You cannot just write x squared. You must account for the general case. So knowing the general cases of what you're dealing with and substituting in is really, really common, because this will be all about making a model for you typically. You're going to get the right numbers and then you're going to use the model. So I say they've been too nice because they are absolutely, they're never going to tell you that one there. They expect you to know. What do you need to do? Well, as you may have guessed, substituting in and simultaneous equations will be the way to go. Okay. This one here, so this is clearly a quadratic as well. I can tell from the symmetry. So what's going to be really useful on here? Well, you know, 2 minus 2 are being given as roots, aren't they? And 0, 4. So if we go back to what I was just saying, for example, if you use the quadratic in this version here, you could straight away say that that's a 4. You could then do simultaneous equations twice and you'll get the answer. But you may, if you can spot it, b will actually be 0. Whenever you have a quadratic that's completely symmetrical, like think about this example and think about this example, whenever they're completely symmetrical, the b part is 0, isn't it? So this is a better example of a modelled quadratic. Okay, so I hope I've given you some intuition there for making sure that you're really, really, really clued up with your signals. One nice way that you can do this is if you've already done lots of papers already. So say you've done all the official papers. Make sure you do what are called the shadow papers. The shadow papers for the ones that you've already done. And go through like I have here, okay? And if you really, really know your stuff, you should be able to, perhaps maybe like 70% of the questions or something, you should quite quickly be able to put your finger on the pulse of what's the question all about, okay? The 30% that's left over, that's where all the work should be. And if you can spot these signals, you know, of course I'm going to go through and I'm going to read through things in more detail. But if I can spot the signals at the start of the question and then I read and it's confirming what I'm doing, it means that I can be confident that my first and second step is correct. And it's all about getting that first step correct because you don't want to lock yourself out of the paper. So do some time, perhaps today, tomorrow, to just make sure that you feel confident in your signals and you can spot them.